Hi everyone, and welcome back to the Exactpro YouTube channel. We're excited to see you at session 5 of the Python for Machine Learning Bootcamp. Today we'll talk about Pandas. Pandas is a data analysis library for working with numerical tables. Its target formats include XLS, CSV, and others. Pandas offers data structures to analyze and manipulate the data by using Python. Overall, a library is a set of documents and pre-written code. As for the documentation, the Pandas website contains 4 sections in the Documentation tab. These can be studied either consecutively or in parallel. If you're new to Pandas, we would recommend that you study them one by one. As to the pre-written code, conveniently equipped with an intuitive interface for its use, it can be found in directories that contain Py files. These directories can in their turn contain other directories and files and so on. So, these Py files are called modules. There's a package that contains modules and is essentially a folder. A package has to also contain some auxiliary files, but since we won't be creating packages, their nuances are irrelevant at this point. We have to understand that any Python package is a set of Python scripts that you can read and modify as you see fit. This is the essence of the open source community. Anyone can look into other people's code, see its internal setup, and build on it. So what is a package? Let's first see if you have the Pandas package installed in your collabs. To do that, enter pip show pandas in your code cell. You can use or not use an exclamation mark and see if it works or doesn't work without it. Sometimes it does and sometimes it doesn't. After that, you'll see the version of your Pandas package. Mine is 1.1.5. If you're not seeing a version, you can use the pip install pandas command. What is pip? It's also a package. This one allows you to install, update, and remove other Python packages. Somewhere in the Python directories, pip will store scripts that we'll be able to manipulate via the pip utility. So, what do we need to start using Pandas? In the first line of code, we need to import the actual package. The rule of thumb used in the industry is to import it by calling it PD as a short version of pandas. So this as part needs to be there. As is followed by PD. PD is merely a pseudonym. You can access pandas directly, but PD is obviously a faster way. How do I read a tabular data file with pandas? First and foremost, make sure your files are connected to Google Collaboratory. We're going to access the files via Google Drive. This is not the only way, but it's the one that suits our purposes. As to the other ways to read a file, you can easily Google your options. These are less difficult and more intuitive ways anyway. For instance, one is accessing the file from your computer. Another option is uploading a file into the current session while bypassing Google Drive. So first, we connect the Collaboratory to Google Drive via the side menu. Click this folder and click the Google Drive icon. If your Jupyter notebook is empty, you will get this code fragment. This should be added automatically, but it does happen that it doesn't pop up. In that case, you can try and type it in. And sometimes it even works without these 2 lines of code. However, if you're planning on executing your notebook from beginning till end via the runtime run all menu items and without manually loading your file, it's recommended to connect it to Google Drive via this code. Otherwise, you'll raise a file upload error. After you connect your notebook, you will get a message about the drive being mounted. This is the root directory of your Google Drive. There may already be some tabular data files on your Google Drive. If not, then you can use this link from our notebook in the description below the video. After you upload the file to your Google Drive, you can import it into your collab. So, how do we import the file? First, locate your file, then right-click it. Mine is a CSV file. Then copy the path and insert it into this code. So I'm accessing Pandas, calling the readCSV method, pass the path I copied to the method which is being copied with single quotes, and the entire corpus of tabular data will be stored in your data variable. As the next step, I display this tabular data. Jupyter notebooks are good at visualizing Pandas data frames, which are your tabular data. In my file, I have 3 columns and several rows of data. All of them get to be displayed here. If the text is too long, we won't be able to display all of it. Let's try and do the same with the Excel format. there's a corresponding read_excel method. Similarly, we pass our file path to it. And now, meet the new method, head. In this example, it's head3. What it displays here is the first 3 rows of our data frame. These 2 files contain the same data. One is a copy of the other, so the same information is output. How else can we analyze the data? What data type does our variable belong to? In this case, it's a data frame. It's the main class in the Pandas package. The class has quite a variety of methods and functions. Data frames are 2-dimensional. They contain data structured as rows and columns. You can work with this data structure by accessing rows or columns. This is convenient, unlike working with a list of dictionaries, where you have to access rows first and then use column names to access the respective column data. In a list of dictionaries, you can access all values by a key, and you will have to write your own loops to do that. Pandas, on the other hand, lets you easily access columns by name and get data while working vertically or horizontally. What are the typical operations we can perform with this data? Similarly to slicing lists, we can slice data frames. The square brackets will have to contain the indexes of the required rows. Let's see how it works. From rows 2 to 6, including 6, I'd like to get every third one. What I get is rows 2 and 5, because 2 plus 3 makes 5. So it's pretty similar to what we've discussed in the context of lists. As to columns, these square brackets can also accept conditions. What we do there is ask the data frame to give us the data that satisfies the following conditions. The target column is article ID of the data frame, and the values we're looking for must exceed 1101. The result is displayed on the screen. All the values are indeed greater than 1101. By accessing article ID or any other column name using dot notation, we access the dataset of the entire column. So, if we apply a condition, it's applied to every value in the column. And essentially, we get back a set of true-false values responding to the condition we've put forward. And based on these true-false values, the data frame is communicated via the square brackets, which indexes or rows should be displayed. We'll talk about it in more detail soon. We can also make the conditions more complex. Unlike the conditions we created for loops and if statements, these ones call for an ampersand and some parentheses. The ampersand stands for the logical and the vertical pipe stands for or. And the parentheses are a must, it simply won't work without them. Having performed this operation, we'd like to get a set of data whose article ID is greater than 1101 and less than 2034 at the same time. Right now, we're only displaying the contents of the text column of the respective rows, satisfying these 2 conditions. Please mind that apart from using dot notation and a column name, you can also access columns via square brackets and single quotes, so formulating your request as a string. When we slice a data frame, we get a data frame in return. All the operations we've reviewed are applicable to the sliced part as well. You can access it via indexing, conditions, and so on. As a result, if you're looking for the data from just one column, you will always receive the rows indexes and the values of the requested columns. It doesn't matter whether you access the columns via the string method or via dot notation. In any case, you will receive the column values and their indexes. What is a column? It's a new data type for us. It's not just a list. It's a data class consisting, like we've established, of value index pairs. The values belong to a data type. Having received the contents of the column, we can see its name and the type of data the values belong to, as well as the actual values. This is described in the documentation in great detail. Actually, not all open source documentation is this comprehensive. As a data object, the data we received is an ND array. We won't go into specifics. Let's just remember that Pandas is built on top of NumPy, and an ND array is a NumPy data structure. You might have noticed the dtype variable. It stores the data type of the NumPy package. Let's move on. We can access not just one, but several columns at once. To do that, you can store the list of columns in a variable and pass it to a data frame. Alternatively, you can indicate the required columns in a list. In this case, you'll have two pairs of square brackets. These are identical requests. One uses a variable and the other requests the columns directly. The square brackets help us create a list of columns. As a result, we get a data frame consisting of the two columns we requested. If you have prior experience with SQL, you may have heard of aggregate functions. They work here too. For instance, we can find out the maximum value of our article ID column. We use the agg method and pass it the name of the function that has to be calculated for the entire column. We can put in several such functions. The resulting data frame will have the names of the functions in place of the index, the minimum and maximum values of the column we indicated, article ID, as well as the corresponding text. So, this line is executed. As you see, you can apply these functions to one column or to several columns at once. Similarly to the previous example, you need to pass a list of strings with column names if you want to refer to two columns. And the agg function is also passed a list of functions to be calculated for each of them. It happens that, let's say, you want to calculate some functions for article ID and others for text. In that case, we would also receive a data frame, except a part of the values will not be available. For example, the count for text is 9. 9 stands for 9 entries. For article ID, we've calculated the min and max values. But why did we get nan, and what is that? Nan is short for not a number. It's used to represent entries that are undefined. It's also used for representing missing values in a dataset. So, what can we do with nan values? Let's say we're still calculating the aggregate functions, but we want to replace nan values with zeros. We can use the fillNA method and put in what we replace them with. Our new argument here is inPlace. If inPlace is passed true, the replacement will take place in the current version of the data frame and on the current data. The data won't have to be reassigned. If we choose not to use this argument, then we can store the result in a new variable and keep the previous result. So if you're reluctant to reassign data and write equals several times, then we can use this argument. However, if we need both states, the initial one containing the nan values and the one where they are replaced, we don't have to use this argument at all or pass it false because the default value passed to it is false. As a result, we get our zeros in place of nan values. We can also create new columns from scratch. For example, I can write that I need a new column with this title and all its values are equal to 1. Then such a column will be created. Unfortunately, it doesn't work if you're using dot notation because dot notation is used to access existing columns. And since this data frame doesn't have a column with this title, we can't access it. In addition, we can store a specific value in a specific cell. The add property is used for that. The first argument it accepts is a column name, and the second one is the index. Here's the column name, and the index is 3. We've stored an empty row here. If we get confused and switch these arguments, putting 3 first, followed by the column name, it will mean that we are accessing a column titled 3, which we don't have, so Pandas will create it for us, and the text index, which we don't have either, which will also be created for us. Pandas will add both a new row and a new column. Empty cells will be created at the intersection of the column title and the index. And since we haven't stored anything in the cells other than the title cells, nan will be stored there as an undefined number. Data can be grouped. Again, if you're familiar with SQL, you may have performed the group by operation. Let's say we want to group the data by the category column and count how many values there are in each category. Having performed group by and having passed the title of the column we want to group the data by as the argument, and having called the aggregate function, we receive the following data frame. We can now see that the categories have become indexes and the column titles have gone up. Category is now the line below them, and it contains the index names. They are the category names from the data frame, and they are followed by the count of rows related to them. 5 articles belong to the business category, and the rest of the categories had 1 article each featured in them. Now, for your homework that will help you practice what you've learned, we suggest that you download a Titanic dataset, import it to your Google Drive, and look at its contents. It's actually very interesting. You can also find its description online and study it in more detail. Here's a short version of this description, and this is what you can do. First of all, you will try and replicate this code and then try and get such a data frame. So you have to make your data look like this. You have this notebook to rely on. You can retype it and look at the slices you're getting and so on. And then you make sure that your numbers match this table. If you're filling up for a bonus task, try to also make the data frame look like this. P class will become an index and will correspond to column names 1, 2, and 3, and this should be followed by the survival stats organized by class. If you succeed in making it look this way, excellent job. And if not, then you're welcome to let us know in the comments section below this video. Don't hesitate to get in touch if you need help with this. Thank you for your time and attention. I do hope that you liked the video. If you're finding this Python for Machine Learning Bootcamp helpful, remember to like our videos and subscribe to the channel for more educational content. This is all for today, and I'll see you at session 6.